Hello everyone, hope you're all rocking. Today I'm going to discuss the second question from Cracking the Coding interview book. It's the second question from the chapter titled Arrays and Strings. Here, we'll be given two strings and we have to find out if they are permutations of each other or not. So, the first step to solve this problem is to clearly define what on earth does a string being the permutation of another string means. You see, the permutation of a string is another string that contains the same string, albeit in a different order. For example, the strings ABCD and BDCA are permutations of each other. Here, in this problem, I'm going to treat lowercase and uppercase letters to be different. So your uppercase A is different from your lowercase a. In the first naive approach, I would first compare the length of the two strings. If they're different, then no point in moving forward because they can't be each other's permutations. They have to have the same number of characters. So if they don't, I'd return false. You can consider this as the first checkpoint for the two strings to have passed to be considered the permutations of each other. However, if the lengths are indeed equal, I would first sort the two strings. You see, the sorting happens based on their ASCII values. After sorting, both the strings would look something like this. As you can see over here, all the characters would be arranged in non-descending order of the ASCII values. Now, I'd simply traverse through both the strings. If at anywhere the corresponding characters are different, then I'd return false, indicating that the two strings are not the permutations of each other. Now, let's jump onto the coding part. So, over here, I'm creating the function checkPermutations1, which would take two strings s1 and s2. Then I write the if condition to check if both their lengths are equal or not. If they're not equal, then I return false. Otherwise, I would first get the length of any length of any of the two strings, since they would be equal in every other case, and store it in a variable n. Then I would sort both the strings like this. Now here I am running a for loop to traverse through each of the characters in both the strings to check if they are equal or not. For that, here I'm writing an if condition like this. If there are no different characters in the corresponding strings, then that would mean both the strings are basically the same after they are sorted, hence I will return true in those cases. Now let's check this function that we've made. I will make three strings where s1 and s2 would be each other's permutations, and I would hope that my function would give true in that case. I would also make another string s3, which would be different from the first two. Now passing s1 and s3, it should give me false. So let's run this. Running this. Very well. It is giving me the expected results. Alright. The time complexity of this method depends on the sorting technique being used. Here I have used the sorted function whose worst case time complexity is O of n log n. That's because it uses the tim sort, so the time complexity is going to be O of n log n in this case. Now let's try to optimize it. If you think about it, in the English language there are 26 letters in the lowercase and 26 in the uppercase. Your two strings could contain not only these letters in whatever fashion, but also the special characters that are present both on your keyboard and not on it as well. In total, there won't be any more than 256 characters, including all the letters in the English alphabet, numbers, etc. So the idea is pretty simple actually. I will make two lists, each corresponding to the two strings. Both these lists would contain 256 values, which would all be initially some default value, like which would be initialized to some default value, like let's say 0. So you'd have two lists with 256 zeros in them. Now, when I traverse through both these strings, I would like to fetch the individual character's ASCII value and change the value from 0 to 1 at the index corresponding to that character's ASCII value. That would mean, in a random string, let's say ABC, I would want to change the 97th, the 98th and the 99th value from 0 to 1 corresponding to the characters A, B and C respectively. To do this, I will increment the values at these indices by 1. I'm doing this because in case of repetition, I want the count to increase. So, if a string contains 3 A's, let's say AAA, then I would want the 97th position to be 3. I would do the same for the second string. So the string which might be a permutation of the first string, let's say BCA, would also have ones in the exact same indices of its list. Then I would compare both the lists. If the lists are same, that means the two strings contain exactly the same characters and hence are permutations of each other. Otherwise they're not. So let's code it. Here I'm creating the second function, check permutations 2, for the second approach, which would take in two strings as the parameters S1 and S2. First, I will check if the length of the two strings are equal or not. If they're not, I'd return false. However, if they are equal, I will continue with my approach. Here, I'm making two lists, count 1 and count 2, and storing 256 zeros in both of them. I'm creating the for loops to iterate over each string and increment the values by 1 of their characters at the index, which is equal to the ASCII values. Now we are almost there. Now that I'm done traversing the two strings, I would compare the corresponding elements in both the lists. If they are not equal, I'd return false, otherwise I'd return true. So that's why I'm writing this for loop and inside this if condition, like this. And at the end, I'll return true, like this. So now that we are done with the coding part, let's call it. Very well, it is working. Since I'm using the loop to iterate through the strings, the time complexity of this approach is going to be, guess what? It's going to be of n, yeah? So that was it, we successfully reduced from O of n log n to O of n, our time complexity. So folks, if you liked the video and think it was fruitful, be sure to like this video, and more important, share with your friends who might be prepping for an upcoming technical interview. Till next time, cheerio.